Why do packet drops happen with packet switching buffers? Imagine sending a letter through the mail, but the mailbox is full when your letter arrives. That's similar to what happens in a network when packets get dropped. Packet switching is how data travels across the internet. It breaks data into small pieces called packets, which move independently through the network. Routers and switches are the traffic cops directing these packets to their destination. They use buffers, small storage areas, to hold packets temporarily. Buffers help smooth out traffic, especially when many packets arrive at once. Think of buffers like a waiting room for packets. When traffic is light, packets move smoothly. But when traffic gets heavy, these waiting rooms fill up. If the buffer is full, new packets have nowhere to go and get dropped. One big reason for packet drops is network congestion. When many devices send data to the same place at the same time, the network gets crowded. For example, if several computers try to send data to a server at once, the buffer at that server's router can fill up quickly. Once it's full, any new packets arriving are discarded. Buffers also have a limited size. If a burst of traffic suddenly floods the network, the buffer can fill up fast. It's like a small parking lot filling up during rush hour. Once full, no more cars or packets can fit, so the new ones are turned away. Inside routers and switches, packets sometimes compete for resources like memory or processing power. If many packets arrive at the same time, they might get held up temporarily. But if the internal buffers are too small or overwhelmed, packets will be dropped instead of waiting. Another cause is when data moves from a fast link to a slower one. For example, if data comes in at 10 gigabits per second but can only go out at 1 gigabit per second, the buffer fills up quickly. The excess packets stay in the buffer temporarily, but if the speed difference lasts long enough, the buffer overflows and packets are lost. Traffic bursts are another factor. Data often arrives in quick, unpredictable bursts rather than steady streams. Buffers absorb these bursts, but if the bursts are too large or happen too often, the buffers fill up and packets get dropped. Packet drops happen naturally because buffers are limited and traffic is unpredictable. While some loss is normal, too many drops slow down the network and cause delays. That's because when packets are lost, they need to be resented, which takes time. Understanding this helps us see why managing bandwidth, latency, and congestion is so important. Techniques like controlling how much data is sent, shaping traffic, and prioritizing certain data help reduce packet drops. Networks also use special systems like content delivery networks and internet exchange points to spread traffic out and keep buffers from overflowing. In the end, packet drops happen because buffers can only hold so much data at a time. When traffic exceeds what the network can handle, packets get dropped. This balance between buffer size, traffic flow, and link speed is a key part of how the internet works smoothly, or sometimes not so smoothly.